Okay guys, welcome back to the next episode in the DirectX 9 tutorial series. Now, I was asked recently to do a DirectX 11 tutorial series, and I'm going to, and I'm going to pretty soon. I just have to grasp a little bit more about DirectX 11. It's more difficult because you have to actually handle some stuff that DirectX 9 handles for you. So to start, in the DirectX 9 tutorial, let's see where we are. I believe the last tutorial ended with me showing you how to make a shaded cube. So we had this. Now, what this tutorial is going to cover, as you can see, is it's going to cover timing, so high performance timer. Basically, we're going to capture the time that elapsed since the last frame, which is also otherwise known as delta time. And we're going to also handle when the device gets lost. So as I showed before, if I were to hit Control Alt Delete and then come back, you'd see everything crashed. That's because the device goes into a lost state. So to start, what we're going to do is we're going to capture delta time. Now to do that, we're going to create another attribute in here. Basically, it's going to be a float, and we're going to capture this is going to be for the frames per second, which we're also going to capture because once we have delta time, we can capture the frames per second. So I'm going to show you how to do that too. But then what we're going to do is we're going to go in here to our D3D application class. We're going to go up to here where the update is, where our message loop, our main render loop is, application loop. And what we're going to do is here's where delta time should be placed. First, what I have to introduce you to are some methods. The way high performance timing is done on Windows is using these functions called query performance frequency and query performance counter. Now what query performance frequency does is basically this takes in a pointer to a large integer, which is basically a 64-bit integer type. It stores the counts per second. So what it stores is counts per second. Now what we're going to use this for is what we can do is, since this is counts per second, and it increments by one count, what you can do is to get seconds, seconds is basically equal to the reciprocal of that. So 1 over the counts per second gives you seconds per count. And what we need this for is what we'll be able to do is just get the difference between the current counter time and the previous counter time. And since that's still a count value, you can multiply it by that reciprocal. So if you have done conversions in chemistry or some sort of math class, you know that this will easily convert out and leave you with the seconds. The seconds since last frame, basically delta time. So if that made sense, what we're going to do is store counts per second. We're going to query the performance frequency. We're going to have to cast this to a large integer pointer and reference in our counts per second. So now what's going to be stored in here is the counts per second, and then we're just going to get seconds per count, and we're just going to set that equal to 1 over the counts per second. So now we're storing seconds per count. Next thing we have to store is the very first initial previous time. So the very first time the application starts up, we got to store that first, iteration. So we're going to call that previous time. We're going to do query performance counter. This time we're actually querying a counter variable or value, and store that in previous time. So that's it for that. So now you have previous time. So down in here, every time we pass the message stuff, and we actually go into our update. So we're no longer handling Windows messages. We want to actually capture current count. So again, in 64, current time equals 0. We're going to query the performance counter again. Oh, keep doing that. Getting current time. And now we're going to calculate delta time. And what that's going to be is float delta time equals current time minus previous time times seconds per count. So here's where that conversion factor comes in. So we just take the current time, subtract the previous time, and then multiply by seconds per count, and that's delta time. So now we can put delta time in here. Now we're not done yet. We have to remember that we need to reset previous to current after after frame ends. So basically, once this single frame of updating animation or rendering goes through, we need to make sure that we set previous time back to the current time. So we're always, if we're just going to end up subtracting, it would just end up in a strange loop. And it wouldn't actually be correct. So there you go. So now previous time is always current after this first time that we cached it. So now we have the correct delta time. Let's see if it actually works. So the way we're going to do this is, remember in here where we were adding this strange, arbitrary number. Some of you may have noticed that if your CPU runs at a different speed than mine, it would have animated like differently, not like mine did. That's because what delta time does is it makes it so no matter what your CPU cycles are, the animation will always be constant. The delta time value is always constant, regardless of your CPU cycles. So we're going to change this to increment by delta time for all these. So delta time, and if we run now, what we should see is it's still animating, as you notice. However, regardless of what I do, if I were to set my power CPU to power saver, it's still running. Though it's a little bit choppier, it's still animating correctly. The frames per second may have dropped, but it's not moving any slower. So I'm going to go back into high performance. And here we go. So that's that. Now let's calculate frames per second. So the way we're going to do this is basically we're going to create a function. So we're going to go into our header file. We're going to go down here into initialize. Underneath the initialize direct3D, we're going to create a method that will calculate frames per second. So void calculate FPS takes in float delta time. And what we're going to do is we're going to implement that in here. So down at the bottom, above this, I'm going to do void d3d app calculate FPS, pass in float delta time. There we go. So what we need to do is we need to create some two variables. We're going to make them static because there's no need for them to be constant across each recreated every time this method's called. So we're going to create static int frame count, static float elapsed time. And what we're going to do is we're going to increment these. So we're going to increment frame count. So frame count plus plus. And then we're also going to increment elapsed time. Now elapsed time gets incremented by delta time. Basically the elapsed time since last time this was called. And then what we're going to do is we're going to check that elapsed time and see if it's ever greater than or equal to 1. So basically if this elapsed time is ever greater than or equal to 1 second, essentially, so 1 second has passed, then this frame count will tell us how many frames actually happened in 1 second. So then you get the frames per second from that, if you can see how that works. So nothing in here will ever get called until 1 second has passed. So basically, then the FPS value we made would essentially just be equal to the frame count. If that makes any sense? Yeah. So it would just be equal to the frame count. Now that should be actually casted to a float, now that I think about it. But, yeah. There we go. So then what you need to do is we want to output this. So we're going to output FPS to window title. So the way we're going to do this is we're going to use something called a string stream. So we're going to go string stream SS. We're going to create a string stream. The problem is string stream we need to include, so we're going to add some includes to here. We're going to add SS stream. I think that's all we actually need. Not mistaken. Let's see if I run this. Yeah, okay, there we go. So got rid of that error. And what we're going to want to do is we're going to want to output to that. Now this is how you use a string stream. I don't know if you've ever used cout or cin, some of the IOStream types, input-output streams types, but they use these carets. These carets means you're outputting. This way means that you're inputting. So we're going to output to the stream. We're going to output our apptitle.cstring. We're going to output FPS like that, and we're going to output our FPS value. So then we're just going to set window text, our application window handle, and then ss.str.cstring. And what should happen once we actually call this, it should display the FPS at the top of our window in the title bar. And then finally what we need to do is reset elapsed time and frame count. So we're going to set frame count equal to 0 and then elapsed time equal to 0, because it needs to recalculate that after each frame. So let's actually call this. So what we'll do is we're going to go up here, and right before it updates, we're going to call, we're going to calculate FPS. We're going to pass in delta time. So what should happen now is it should display the frames per second right there. So currently this is running at 590, 600 frames per second, which is decent. Not really. It's kind of because I'm running. The reason it's so low, you may think, wow, that's a lot of frames per second. Well, keep in mind that we're only rendering a cube. Games which are massive are pretty astounding that some of them run at 60 FPS. But it's because I'm running my my capture software, so yours should generally be upwards of 1,000. But yeah, and I kind of want to add another space to that right after. I want to add a couple maybe. See how that works. Yeah, there we go. So now you have the FPS up here, so you can keep track of the frames per second while your applications are running. Okay, so now here's the more complicated part of this. What we have to really do is we have to figure out a solve for when the application loses its device. So to start, I'm going to have you create a couple. We're going to create a couple booleans in here. One is going to be mb handle device lost, and then the other one is just going to be device lost. So this one is going to be true if we actually want to handle device loss. So the reason I have this in here is so that if you want to kind of turn on and off the device handling to see the difference, you can always do that. And then device lost will be true if the device is lost and false otherwise. So what we're going to do is in here, we're just going to always set these to equals false, and the handle device lost I'm also going to set to false. So initially it's not going to handle the device, but you should probably set that to true in yours. I'm just doing this for the tutorial. And what we're going to do is in our test, what we're going to do is we're going to create some two methods called invalidate device objects and restore device objects. Should be have an S. And what these are going to do is basically I have to explain kind of what happens when the device gets lost. See these things like vertex buffer, were all pretty much everything in here in this initialize is part of the device object. Like these are device objects. They're created and stored on the device, and when the device gets lost and has to be reset, all of this stuff basically is no longer stored by the device, so it doesn't even know about any of this. So if the device gets lost, it has to get all of this stuff reset. Like all of this has to be redone, basically. So what we're going to do is we're going to pretty much first block out these methods. We'll, set them up. So test app, invalidate device objects, and I'll explain that one, and restore device objects. So in restore device objects, we're just going to take literally all of what we had in here, the index buffer, everything, and we're just going to cut it. We're going to paste it right in here. So now this is going to be in the restore device objects. Now we're still going to have to call it here. So we're just going to recall that, so to initialize everything. So we initialize all that. And then what we're going to do is I'm going to explain what invalidate device objects means. Since these are pointers, especially, pointer objects should never be just floating around in memory when you're done with them. They need to be destroyed. Otherwise, you get memory leaks. Now, a good way for me to explain this would be like Fallout New Vegas. This is from my basically my assumption and kind of study of what happened with that game is when it came out, especially in the PS3, their file sizes kept getting bigger and bigger for your save files as it went on, and they came out and said that it was due to memory leaks. Now, it's probably because there were objects that were stored as pointers in their game, and when you killed the enemy or something, they just stayed in memory and they didn't get destroyed, like they didn't get released. So it got saved to the file and it stayed there forever. So you always want to destroy your pointers. Remember that. Now to do that, what we need to do is we need to go into our utility. We're going to create another namespace. We're going to call this one namespace D3D. It's just going to be the general D3D namespace. So what we're going to do is we're going to create some template methods. So template class T void release TT. So it takes in a basically any sort of object, whatever object you designate here, whatever type, it'll just take that in. And then if that actually exists, what we're going to do is we're going to call release on it, and we're going to set it to null. So this is basically what this does is on any COM object, so component object model class, so that's all the direct 3D stuff. They all implement basically a interface that gives them this release method, so you'll be able to release them from memory. We're going to create another one called delete, same deal. Basically, it'll check to see if it actually exists. It'll call delete, well, not that, delete T, then set T equal to null. So basically this is just a safe way of deleting objects. So you delete it and then you make sure that it's null. So there you go, that's all we really need for that. So then what we'll do is in the invalidate device objects, what we want to do is we want to delete not only the objects created in here, like the vertex buffer and index buffer. What we want to also delete is the device and Direct3D interface. So we're going to delete the index buffer, release the index buffer. We're going to release the vertex buffer. We're going to release the actually, do I really want to do that? No, I don't want to do that. In here, we only want to release the index buffer and vertex buffer. In another method we're going to create back in here, we're going to create one called, which is going to be here. It's not going to be virtual at all. It's going to be just called shutdown. And generally, you can kind of guess what that would mean. What this will do is it will be called, I'm just going to create it here. It will release Direct3D from memory. So we're just going to call release on MP device 3D. We're going to call release on Direct3D. Now I do these in reverse order because it's always good to do them in reverse order from when you actually declared them. So we got these being released. Now where is that going to be called? Well, right after this message loop ends, what we want to do is we want to shut down right before we return the error code. So we want to go shutdown, and there you go. So that's that. So we have those correctly releasing. Now, in invalidate, we only want to really validate these because these are the things that are actually going to be recreated. And those are the only pointers I think we have. There you go. And well, those are too. We should probably release those, but I'm going to forget about that for now. And that's pretty much it. So now I believe we're good to go to actually handle the device handling. So all that's going to happen here. It's going to happen in our render function. Okay, so to start, what we're going to do is we're going to store a hresult object. We're going to create one. Basically, what this does is you'll notice pretty much all these Direct3D methods return an hresult, and this just stores the error code associated with it. So if this fails, it will return some sort of error code that you can check to determine what happened. So what we're going to do is we're going to first check to see if we actually should handle. So if that's true, if we want to handle it, then we want to check to see if it actually is lost. So if it's not lost, then we don't do any of this. And the first thing we want to do is we want to check to see if failed HR equals device 3D test cooperative level. Now what this method does is basically tests to see if the device 3D is actually cooperating or working with the hardware, with your computer and with your application. And if this fails, then one of three things could be the problem. So we're going to check those. So if HR equals D3D error device lost. So if it returns that the device is lost, then we have to just return, because there's nothing we can really do. Yeah. Next is basically we want to check to see if D3D error device not reset. So if it's not reset, but it's clearly there, able to be reset, then we want to actually reset it. So first we have to invalidate device objects. Conveniently we have that method. Now we want to reset the device. So we're going to set HR equal to mbdevice3d reset, and we're going to pass in our d3d present parameters. And finally, we're going to restore device objects. So there we go. So you invalidate them, meaning you destroy them, basically. Then you reset the device, and then you rebuild them. And there you go. So, yes. But first, we should probably check to see if that even succeeds. So, if failed HR, we want to, of course, display a message box. Sorry. Saying failed to reset device. Pass in null for the last ones, and then we're just going to return to break out of that. And that should be fine for that. Yeah. Now, of course, we want to return if none of those are the case. And up here, it might be a good idea to basically sleep the thread. So we're just going to call sleep for like 100 milliseconds. What this will do is it'll basically free up the CPU for very small amount of time to allow it to do other stuff, so that it might not actually determine that the device is lost. It might always hit this, but you never know. So then what we're going to do is, after all that, it should be false if this all runs correctly. Yeah, it should be it should be false. And then if we go down here, present also returns an hresult. So what we're going to do is we're going to set it equal to that. And again, what we're just going to do is we're going to check to see if the device is lost. So if that H result that we get from checking present, if it's lost, then we're just going to set device lost to true. So then that will bring us into this, and then we're going to actually handle it and then fix it, etc. So that should be all we needed. So to test it, I'm going to add one more thing to the update. So in our update, what I'm just going to do is, actually no, I won't even add it to the update. I'll just add it to our right in here. We're going to catch WM key down, and then we're going to do a switch on W param, and then case it's a virtual key F1. What we're going to do is set handle device lost equal to the opposite of handle device lost, so I can toggle. Basically, just it allows for toggling, and return 0 for both of those. And hopefully this works. Now it should. So here's this. It's running fine. I hit Control Alt Delete. I come back. It's not working, but well, no, it is. Let's see if it works. Yeah, so it works. So see, we rebuilt and everything. However, you notice that our frames per second just got completely screwed up. That probably is because it shouldn't actually calculate when the device is lost. So if I were to disable device handling now and do it again, what you'll notice is, see how that's like an amazingly large FPS? That might actually even be true, the true FPS, because nothing's even happening. Not sure, but it's kind of relevant, you know, if you have a 500 and 600,000 frames per second. So, whoops, just exit again. So now I hit F1 and we're back to normal. So there you go. So now you're handling basically the destruction of the device and the rebuilding of objects. So remember that anytime you have objects, once we start building classes that incorporate this stuff into it, it's going to be shrunken down to a lot smaller. But again, always remember that every time you reset or have to reset the device, anything graphically that you built needs to also be reset. So that's it for this tutorial. I hope you stay tuned for the next one. Thank you for watching. Peace.